Good morning and welcome. Well, it's going to be another interesting day as far as the Indian Space Research Organization is concerned. After a successful landing on the moon, the Indian Space Research Organization, ISRO, is ready to launch the Aditya L1 mission to study the sun at 11:50 a.m. from the second launch pad at Sriharikota. I'm going to be over here with my colleague Pallav Bagla as we bring you all of the important details with the countdown having begun. What is this mission all about? It is all about pure science. So in the next couple of minutes, I'll break it down for you what exactly to expect. The 1,480 kilo spacecraft will be carried by India's workhorse, the Polar Satellite Launch Vehicle, and put into an elliptical, a highly elliptical orbit. What exactly does all of this mean? What are we trying to do with Aditya? How does the launch actually take place? Well, first off, what is the Aditya mission all about? What we'll try and do is explain through these graphics. For starters, Aditya will stay about 1.5 million kilometers away from the Earth. It will be directed towards the Sun. In other words, this is 1% of the Earth to Sun distance. The Sun, of course, is a giant gas sphere. Aditya L1 will study its outer atmosphere. So that's what the broad goal is. But before we talk about what India's Space Observatory Aditya will do in space, we need to talk about how it will get there. And that is through the PSLV rocket on which it is mounted. Now the rocket being used, and you can see it there, the PSLV XV. PSLV stands for Polar Satellite Launch Vehicle. This is the 59th flight of the PSLV and the 25th flight of this variant. The rocket is 44.4 meters high. In other words, as tall as a 13-story building. The PSLV XV has a launch weight of 321 tons. So what are the sensors on board Aditya to help it study the moon? This is in fact what the Aditya mission is all about. What you see on your screen is the visible emission line coronagraph. It functions as a reflective coronagraph for imaging of the corona and spectroscopy. There's also the solar low energy X-ray spectrometer. It helps in the study of solar flares by measuring soft solar X-rays. Again, we'll explain all of this to you over the next 1 hour. There's the plasma analyzer package. It's designed to understand solar winds and its composition. Also the mass analysis of solar wind ions. There's the high energy L1 orbiting X-ray spectrometer. What does that do? It's designed to study solar flares in high energy X-rays. There's the solar ultraviolet imaging telescope. The images that the solar disk in the near ultraviolet wavelength range provide through this device will be useful for scientists. There's also the Aditya Solar Wind Particle Experiment. This has 2 sets of sensors, 4 in total. You can see that on your screen. These are designed to measure the proton and alpha particles of solar wind and the high energy ions of the solar wind as well. There's a magnetometer which measures the low intensity planetary magnetic field in space. It's a part of a 6-meter long boom that Aditya will eventually deploy once it gets to its position. So those are the instruments on board. It sounds very high-tech. We'll explain it to you, but quite clearly, and this is a common misperception, Aditya is not headed anywhere close to the sun. It would burn out if that were to happen. What it is doing is heading 1.5 million kilometers from the Earth to deploy to a spot in space called the Lagrange point. What is the significance of this? Here are some details. Initially, the spacecraft will be placed in a low Earth orbit. The orbit will be made elliptical and the spacecraft will be launched towards what I just mentioned, the Lagrange point. That's marked L1 in the middle of that screen. The spacecraft will exit the Earth's gravitational sphere of influence. Aditya will be injected into a large halo around L1 or the Lagrange point, as we point out over there. The total travel time to actually get here will be 4 months. So that's important. So what, again, in a broader sense, is the mission all about? This is India's first mission to the sun. Remember, it's not right to the sun, 1.5 million kilometers from the Earth. That's where it will be safe to study everything that we've been talking about. 400 crores, it's a 1,500 kilo robotic satellite to study the sun. It'll look out for solar storms and solar flares. And again, 1.5 million kilometers from the Earth is where it'll be parked. It'll be placed in the sun's halo orbit, again at this Lagrange point I spoke about. It'll delve deeper into less studied solar science. It'll observe the sun's photosphere, the chromosphere and the corona. It'll study how the sun's coronal heating works. It'll identify how solar eruptive events happen. It'll study solar wind, space and weather through all of the instruments on board which I spoke about. This is not a simple satellite. In fact, it is a space observatory. So that's important. It's in a different class of spacecraft. Roll Sam.
There's excitement at the public gallery of Sriharikota, where hundreds of school children from schools across Andhra Pradesh and Tamil Nadu have come here to watch the liftoff live. How does it feel to be here?
We are very happy and we are very proud to be an Indian. And PSLV is going for into the moon for search.
To the moon?
Sorry, moon.
Moon?
Sun.
Okay.
And for researching and on the sun.
Will this help India?
Yeah.
How?
Definitely. Maybe after launching, it will find something on the moon. Sun.
Okay.
ISRO company.
Recently, Chandrayaan 3 had a very successful soft landing on the moon. Do you think this also will be successful now?
Yes, sure, it's a successful. We are praying to the God to be a success on the sun and get more profit information.
I have with me the Santosh's family who have flown all the way from Varanasi to witness this liftoff live from ground zero. Thank you all very much for your time. The government spends around 400 crore for this project. Do you think this money could be used for some other purpose in a better way?
Maybe, but this is also a good purpose. It will also help us. Maybe I think it can also help us building, better hospitals or school.
Better hospitals or schools? You want to become a space scientist at some point in time?
I'll think about that later.
Right now, what's your dream?
To become an IAS officer. IAS.
Very good. As parents, why do you think this kind of project is important?
See, being anywhere is first is proud to any country or any persons, and we are going to explore new area, Aditya, right? Already last mission was very successful, and see how India have created a historical event, right? And in the world we become a first to put our legs on the moon.
Are you proud of this?
Yeah, बहुत proud feel कर रहे हैं. हमें तो बहुत excited है कि और भी project आए जो इंडिया में proud feel कराएं, इंडिया का नाम मतलब वो थोड़ा proud हो हमारे का.
All right. And what's your message for Team ISRO?
All the best. Go ISRO.
Jai Hind.
Jai Hind.
Do more projects like this and keep our nation's name on the top.
All right. Thank you all very much for your time, and certainly excitement at ground zero as hundreds of people gathered to watch the liftoff live, and they hope that coming closer to the successful landing, soft landing of Chandrayaan 3, this mission Aditya 2 would be a big success. At Sriharikota with Suresh, Sam Daniel, for NDTV.
So as we speak about the Aditya mission, remember 11:50 a.m. in the morning is when it's set to blast off. I think it is important to mention that in as much as we love Chandrayaan, we love the Pragyan rover, the Vikram lander, that mission will now slowly come to an end. So that is Aditya. But let's roll graphic 6 and let's talk a little bit about Chandrayaan as well. So let's take these images off and talk a little bit about the Chandrayaan mission. So what exactly has Chandrayaan found on the mission, on the moon? Let's talk a little bit about that. It's been a week of progress. It's confirmed the presence of various metals and elements on the lunar surface. It's found sulfur, aluminium, calcium, iron, chromium, titanium, manganese, oxygen and silicon. It's been looking for hydrogen. It's found a 4-meter diameter crater which it went around. It's measured soil temperature as well. So that's important, and the reason why we need to talk a little bit about, if you can just come back to me, the little bit that the reason why we are actually talking about Chandrayaan is simply because Chandrayaan as a mission, this part of it, right, is going to be coming to an end in about 24 hours or so. So if you're asking, but it just got there, the answer is it was designed for only 14 days. It was designed for 14 days because it's powered by solar sails, and those solar sails need to get the solar radiation that they require to actually power up. But this side of the moon slowly enters the dark side. Chandrayaan 3, the lander, Vikram, it actually touched down when there was dawn on the moon near the South Pole area. But with that dawn now receding and light in that part of the moon going away, there will be no power left. But there are some, including me and my friend Pallav Bagla, who's sitting next to me, who are rather confident that in a finite period of time, Vikram and Pragyan may wake up again, because that's not impossible. ISRO will not get ahead of themselves and say that that's going to happen, because the honest answer is they don't know. But it is a possibility. So as we talk about the excitement of Aditya, and let's just stick to the images if we can of the Chandrayaan project, because that's what we're actually talking about. This is Aditya that we have on the screen. Tell us a little bit about why there is a little bit of hope that Vikram and Pragyan, after going to sleep, may still wake up.
Oh, certainly. See, nothing will go wrong with the satellite or the Vikram. They are solar powered. The batteries would be charged fully and left. But ultimately, once Pragyan and Vikram are put to sleep tomorrow morning, which would be the lunar evening, after that, the Pragyan rover and Vikram lander would remain in darkness for 14 days, but the temperature goes down very heavily on the moon surface to about minus 200 degrees centigrade, and many of the electronics there are simply not able to withstand that cold temperature and they freeze. So there is hope that with full batteries, they can manage to wake up Pragyan and Vikram once the lunar dawn begins. But there is a way of overcoming this. But unfortunately, in this particular mission of India, we did not have a radio heater on it. So there was no radioactive element or heater.
Right.
The Luna 25 had a radio heater. That is why it was to last 1 year, and Pragyan and Vikram are to last only 14 days. But if they wake up and they do science, it will be great. But scientists at ISRO told me, I spoke to scientists today morning, that they've had a dream run with Vikram and Pragyan.
What about hydrogen, Pallav? It was looking for hydrogen.
It is looking for different elements.
Right.
So the elements which they are looking for, they have found several, but mostly metals is what they have found, and they have also found sulfur. But finding hydrogen is not tough, because there is always a possibility there is hot hydrogen there, and there's much talk about helium-3 on the lunar surface, and there are many dreamers who think that you can mine helium-3, bring it on Earth and power cities by a few grams, but that is still far away. But essentially, I think Pragyan and Vikram have given us enough data that Indian scientists for the next 1 year would be very busy writing up their scientific papers, because this period they will get to get the data for themselves. Beyond that, the data will be opened up for the world. That is the
So that will be,
priority.
and ultimately, Pallav, that's what this is all about. You know, it's about collecting data, information, research, analyzing it, and coming out with academic papers, and then enhancing our knowledge.
See, Chandrayaan 3 had twin objectives. One which was
engineering,
which is to showcase soft landing on a celestial body, which essentially for me was a geopolitical statement by India, and we did that firmly and told the world we can do it. And the other part is science.
Right.
The same way with Aditya, we have twin objectives, science and also as a kind of an insurance policy for our satellites. So there are twin objectives. ISRO always does things with many things in mind, unlike many other agencies which do one thing at a time. Even our
That's interesting.
weather satellites initially were both communications and weather, and we were first in the world to have a satellite which could do both things.
Yeah.
So when you have small resources, you have to be very smart.
Okay, we're joined by Dr. Venkateshwara Sharma, former Deputy Director of ISRO. Thanks very much for being with us. So let's talk a little bit once again about the Aditya mission. We actually see the Aditya Space Observatory on our screens just a few moments back, and that of course is the PSLV rocket which will take it up to where it ultimately gets. It will be a 4-month-long journey. But Dr. Sharma, what I think is really interesting is if you help us go through some of the instruments on board. And so what I'm going to do is if we can just roll out graphic number 3 and then we'll have Dr. Sharma go through each of these instruments one by one. So let's bring up graphic number 3 because among the instruments that it has, and let's have this up full screen for just a moment. The first point, the visible emission line coronagraph, which functions as a reflective coronagraph for imaging of the moon and spectroscopy. In simple terms,
Yes.
Dr. Sharma, what does this particular instrument do?
Observing the visible, light coming from the sun, the corona, what you call it as coronography, is the study of the visible rays which are coming from the sun. So, visible rays study is important from the point of view that there is a distance of 151 million kilometers the light is traveling, and it is reaching the earth. It takes about 8 minutes, and it is important to know at 1.5 lakh kilometer orbit, that is Lagrangian, what is the type of observation that we can make on the sun regarding this corona.
Okay, sir. Pallav, why don't you run us through the next equipment over here. So let's change the image to the next point to show the solar low energy X-ray spectrometer, which helps in the study of solar flares by measuring soft solar X-rays. Pallav.
Oh, this is a very important instrument, and many of the instruments on board Aditya, like I was saying, Vishnu, this is a scientific mission, but also a mission which will help protect not just Indian satellites, but global satellites, because this is very, very important. Satellites usually have lots of electronics in them, and once the sun gets angry, which is when it sends out copious amounts of charged particles towards the earth, and when that happens, it literally fries up satellites.
Yeah.
Recently we had the Starlink constellation losing about 3 dozen satellites in space. So you don't want that to happen. India has 50 satellites in space worth about 50,000 crores. So a 400 crore mission, which is a science mission, will also help protect India's satellites. So it's a 2-in-1 mission, and several of these instruments will help us.
That's an important point.
They will help us
It's
give the
advanced
space
warning.
weather.
Besides the science, it's advanced
Correct.
warning.
Advanced warnings. What is called space weather. You have weather on Earth, and you also have weather in space, and that is going to be a key part.
Okay, Pallav, we'll take a break, come back and study the remaining 4 instruments on board. That's coming up. So India's moonwalk to a Sundance now, the Aditya mission, less than an hour away now.
Yes, less than an hour away.
57 minutes.
Less
57
than an hour away
minutes
for
it's
lift
going
off.
to blast off. So let's
long
continue
mission.
this. How long is it? Oh, just today.
Usually polar satellite launch vehicle missions are about 20-25 minutes. Today's mission by PSLV is a 63-minute mission. So once liftoff happens, it's only 63 minutes later will Aditya be separated. There is a long coasting phase in between when everything remains quiescent. They are going and reaching a specific point from where they can, using minimal energy, go to the orbit near the sun.
Okay, Ratan Srivastava, author and independent consultant on airspace, joins us at the stage. Thanks very much, Mr. Srivastava, for being with us. I've been going through the instruments on board, Aditya, and so let's just go through one more. The Plasma Analyzer Package, which is designed to understand solar winds and its composition, also a mass analysis of solar wind ions. In simple terms, what does this instrument do?
So, as you said right now, Vishnu, it is supposed to be designed. It is supposed to understand the solar winds and its composition, because we know that solar winds can range from between 300 kilometers to 800 kilometers, the low and the high wind range, and it interferes with the magnetosphere, and therefore we need to understand how these winds are going to be impacting us. So PAPA is designed, as it is called PAPA. It is designed to understand understand and study the solar winds and how they are impacting us.
Okay. Mr. Srivastava, let's talk about the next one. It's called the High Energy L1 Orbiting X-ray Spectrometer, which is designed to study, and let's have a picture of it up there. It's designed to study solar flares in high energy X-rays. Again, break down the science for us.
I think it's a magnetometer about the Aditya L1, and as you know, that it's supposed to measure the intensity of the interplanetary magnetic field in the space. It has two sets of magnetic sensors, and those two sets of the magnetic sensors, one at the tip of the 6-meter deployable boom, and the other is in the middle of the boom, 3 meters away from the spacecraft.
Right. Okay, that's the boom. That's actually another part as well. But this particular instrument, Pallav?
This is very important. This will give you information about solar storms. This will give you information about sunspots. This will tell you exactly when the sun going to get angry. So this is preparing to understand the deep physics of the sun.
Okay.
So little is understood about the sun, Vishnu. We see it every day. We take it for granted. You and I are here just because of the sun.
Yeah.
You and I would not be there without the sun.
Right.
We take it for granted, but there is so little which is under. It's mysterious, and this is one of them instruments which will decipher some of the unknowns about the sun and also help predict solar storms. The magnetometer is separate. This is a separate
We'll
instrument.
come to the magnetometer in just a moment. I need to take another break, and we've got 3 more instruments on board Aditya, which we need to talk about. And as you see, we've got the exact instrument on screen for you as we continue a discussion on science. How important is that? All right, so less than an hour to go for the liftoff of the Aditya mission on the PSLV rocket, the PSLV XV variant. We're going to be talking about the rocket in a moment, but I do insist, Pallav, that I go through all of these instruments. We've got Dr. Amitabh Ghosh with us as well. He'll tell us about the bigger picture. Thanks, Amitabh, very much for being with us. So the next instrument on board, the Solar Ultraviolet Imaging Telescope. It images the solar disk in the near ultraviolet wavelength range. I think it's important for our viewers to note that this imaging doesn't mean that it's going to be like a photograph that we see. It's going to be very different. The data that the image actually contains would help our scientists. How?
See, it's very important. This particular instrument can function only when it is space-based. It's imaging ultraviolet which get cut off by our atmosphere.
Right.
That is the purpose of having a space-based observatory and a multi-wavelength observatory. So this particular instrument would not work from Earth. It has to be in space. And this is made by Indian scientists specially to understand what they can't understand, even though we have 2 good solar observatories in India, one in Udaipur and one in Kodaikanal, but they couldn't have done this without going to space. So this suite is a special instrument made by Bangalore Institute scientists, and this is going to reveal many details about the sun.
Okay. We are also joined by Dr. Surendra Pal, distinguished scientist and former program director at the Satellite Navigation Program at ISRO. Thanks, sir, very much for being with us. So let's talk about the next key bit over here, which is the Aditya Solar Wind Particle Experiment. This has 2 sets of sensors, so let's have an image of that. So it's got 4 sensors in total, which are designed to measure the proton and alpha particles of solar wind and the high energy ions of solar wind. So, Dr. Surendra Pal, what does this do in simple terms?
See, I mean, the solar radiations starting from the corona, corona is the last thing. So from there, the high energy particles come. The photons come, some part of the electrons also come, and sometimes even neutrons have been observed. Now these particles travel quite a bit and they interfere with our magnetosphere. The Earth has got a magnetic field. So there it interferes, and there we are trying to find out what sort of their speed is there, the count also is there, and from there we can calculate if it comes to the Earth, how much time it will take, what impact it will have it. So, it consists of, as already you told, 4 instruments, and also it contains, not only a particle, it will also analyze the plasma. Plasma is very important because plasma is the 4th stage of matter, so it becomes very important for us. So it also has got a plasma analyzer package, and of course it will be also finding out X-rays and other things also. So it's mostly about the particle count, and it's done in situ. It does not have, it's like earlier equipment UV, so like a telescope. I would like to add here that we have sent earlier one satellite called AstroSat,
right,
in which UV telescope was put.
Yes.
And finding out UV is very difficult, doing that, because UV is available everywhere. And what Bagla told, that on Earth, UV is stopped by corona, our ozone layer and atmosphere both. But ozone layer plays an important part for stopping the UV.
Sure.
UV is harmful. Not only UV, other harmful radiations are also stopped by ozone.
Yes. Okay. The last equipped piece of kit on board, the magnetometer. The magnetometer measures low intensity interplanetary magnetic fields in space. This is interesting because though we don't have the picture here, we'll have it later on. It's part of a 6-meter long boom that Aditya will deploy once in position. And as I understand it, there are 2 sensors on board the boom, one at 6 meters and one at 3 meters. What does this do?
See, this is for in situ measurement. Like Dr. Pal was explaining, there are some telescopic, there are spectrometers, but this is to actually measure what is happening at that halo orbit at that moment. So this is called in situ experiments, and this is one of the experiments which has been designed by Indian scientists, and this is one at a tip and one closer, so you get a differential of what is happening close to the satellite and far away. And lots of this science is already done by scientists at NASA, and we have Dr. Amitabh with us who can explain more of the fantastic satellites and probes which NASA already has.
Let me just ask Amitabh that. Amitabh, why are we putting Aditya in space? How does it help us? What is the larger picture?
So let me talk a little bit about a larger picture. And I guess, I'm going to ask you a question. So can you tell me why the sun shines? What is the energetics?
Why the sun shines? Because of its immense energy, because that energy, is across various bands. Some of it is ultraviolet, some of it is, radiation and other bands that generates energy. And, that is visual, that is something that we can see through our eyes, but it's visible in different, spectra.
Right. You're saying the manifestation, but what is the source? So I don't want to. This is a very big question. We did not know the answer. This problem, you're going to, a class 2 kid will ask you this question. And we didn't have the answer until 1955. There was a group at Caltech who published a paper saying it happens because of nucleosynthesis. And a larger part of the 1800s, there was a huge debate between Charles Darwin, the biologist, and Lord Kelvin, a physicist, about what powers the sun. And there were different theories, but nobody thought that nuclear energy powers the sun. And then Einstein walked into this debate and provided the first hint. So nuclear fusion generates all this energy in the sun, and that's why the sun shines. And not only this, there's a very interesting thing. all the materials that you see on Earth, all the elements are formed, most of them are formed in the sun or in a sun which existed before our sun. So giving you an example, our sun combines 2 hydrogen into a helium. But if it was a bigger sun, then it could combine a helium and a carbon to form a nitrogen, or maybe even higher, silicon. And so this process goes on until iron.
Okay.
So everything that you see around us is actually formed in a sun. And so now you'll ask me, our sun is very small, can just produce helium. So what about the hemoglobin, say, in our blood that goes through our veins? That has iron, right? So where is that iron coming from? The iron is coming from a sun which existed at the location of our sun, maybe 1 generation or 2 generations. So the universe is 13.5 billion years old. Our sun is just 4.5 billion years old. So there must have been 2 suns in this local area of our Milky Way, where there were 2 suns. And so they were much larger suns, and that's what produced the iron.
Right.
And that's what we use. And that produces the carbon, which caused human life to evolve on Earth. So the reason the sun is so important is it constitutes 99.8% of the total mass of the solar system. So the other things in the solar system that we see, like planets and stuff, they're actually a very negligible portion. The solar system is all sun. And if you think about stars, do you know how many stars are in the universe? We didn't know that. We came to know in the 90s, mid-90s, by an accidental experiment on the Hubble Space Telescope. Each galaxy has 1 trillion stars, and there are 1 trillion galaxies. That makes it 1 followed by 22 zeros to 1 followed by 24 zeros suns in the universe. So if we really need to learn how these suns and solar stars operate, and then we can, and they constitute most of the universe, the trillion suns of the universe. So this is a very big reason why so many probes, etc., are going on in all directions, and so much theoretical work. There is dark matter. The visible matter is mostly locked into this suns, but there is dark matter we don't understand. Then there is interstellar matter, which is still negligible compared to what is stored in the sun. So it's a very fascinating, and it provides you with a perspective of how insignificant we are in the universe.
Absolutely. Well, the images that we have on our screen right now are of the PSLV XV launcher, the rocket, and another 40 minutes, Pallav, to go before liftoff takes place. 40 minutes, 12 seconds, and counting down over there. Everything seems okay for the moment. It is a very reliable rocket. I'll talk about the rocket as well. We need to. But first, let's bring out graphic number 1. What exactly we are trying to talk about, more specifically about Aditya. What is the Aditya mission all about? Let's go through a couple of basic points. For starters, Aditya will stay about 1.5 million kilometers away from the Earth, directed towards the Sun. This is 1% of the Earth to Sun distance. Now, the Sun is a giant gas sphere. Aditya L1 will study its outer atmosphere. That's what the goal is. But before we talk about what India's space observatory Aditya will do in space, we need to talk about how it will get there. And that is through the PSLV rocket on which it is mounted. So let's talk about the rocket. The rocket being used, and you can see it there, live images, is the PSLV XV. PSLV stands for Polar Satellite Launch Vehicle. So let's bring the images up of this graphic. This is graphic number 2. You can actually see it. Let's have this up full screen, please. This is ISRO will use its PSLV XV rocket, or Aditya. This is the 59th flight of the PSLV and the 25th flight of this variant, which is the PSLV XL. The rocket is 44.4 meters high, in other words, as high as a 13-story building. The PSLV XV has a liftoff weight of 321 tons. Now, we've spoken about the sensors, so let's actually move to graphic number 4, and this is something that we've not looked at. Quite clearly, and it's a common misperception, that Aditya is not, it's not actually headed very close to the Sun. It would burn out if that were to happen. What it is doing is that it is heading 1.5 million kilometers from the Earth to deploy to a spot in space called the Lagrange point. What is the significance of this? Here are some details. Now let us have this graphic up full screen. Initially, the spacecraft will be placed in low Earth orbit. That orbit will be made elliptical, and the spacecraft will be launched towards the Lagrange point. The spacecraft will exit the Earth's gravitational sphere of influence. Aditya will be injected into a large halo around L1 or the Lagrange point, and that the total travel time is 4 months. So let me put that question across to Dr. Surendra Pal. Sir, what is the Lagrange point and why are we trying to get there?
See, it's a two-body problem. We neglect the influence of other planets and say satellites like Moon, etc. It's a two-body problem between large bodies. One is Sun, another is Earth. They attract each other. So at the Lagrangian point, which were named after one French mathematician, and at these points, the gravitational pull or gravitational force of Sun and Earth, they almost get neutralized. So in that halo orbit, which is around 177 days, if you put any object there and with the minimum fuel, it can remain there and it will directly look at Sun. First thing is, this is the point L1. If you connect the Earth center and Sun center, it comes on that axis, directly on that one. Second thing is, if you go to L3, L4, L5, there are 4. There also same thing is there, but we don't get a direct view. I mean, in all the time, here 24 hours we'll get a direct view, and Earth does not come on the view. There is no occultation. Earth, Moon, no planet comes on the view. So that's one importance of this one. Now L1 also, it's not that we don't need a fuel there. See, what we say is that there is a two forces. I talked about Earth's gravitational field. If in the childhood, many persons must have put a stone on a rope and taken around. So it has two forces. It comes from the circle. One force which is inside is called centripetal force, which goes outside is centrifugal force. So here the centrifugal force of the which will be there on the spacecraft is almost compensated and by the gravitational field. So so there we have to spend very little fuel, and we go in that orbit, and it always points towards the Sun because there are complicated optics inside it, and of course the in situ 3 situations are there, and so all those things we can do very well at that L1 point. That's why most of the like 22, I think 22 spacecrafts have gone, 5 systems are working there. So out of them, all are in L1 orbit, and it's a large orbit. So 177 is a large area it covers. It also is a perpendicular to that axis. These two things are there. So very important as far as viewing point of view is concerned. I hope I have made it clear.
No, you have, sir. We're going to take a short break at this stage as we see images from Sriharikota of that rocket, the PSLV XL, and when it's all going to sort of happen in the next 40 odd minutes or so. So do stay tuned right here on NDTV as we bring you with some excellent panelists from around the world everything that you need to know about the significant launch.